Hello students, welcome to online maths classroom. This is part 2 of our topic relations and functions, and in this video we'll learn about functions, its types, graphs and solutions of exercise 2.3 along with miscellaneous exercise. So let us start with it. So let us see what are functions. In this section we will study a special type of relation. Special type of relation is called function. Okay. Special type of relation is called as function. It is one of the most important concepts in mathematics, and we can visualize a function as a rule which produces new elements out of some given elements, right? So function is basically a rule which produces new element out of some given elements. Now there are many terms which are associated with our function, that is your map or mapping, which is used to denote a function. So let us formally define now a function, a relation f from a set A to set B. It is said to be a function if every element of set A, right? Each element of set A has one and only one image in set B, has one and only one image in set B, right? So as we did if you remember in our part 1 video, we framed a function like with the names A Ali, B Bhanu, B Binoy, right? So B Bhanu, B Binoy, right? Two ordered pairs are giving same first element. So that is the relation, but that will not be a function. Okay, so that is not allowed here, right? Such that domain of A and no two distinct order pairs in F have the same first element, right? So our function f is a relation from non-empty set A to non-empty set B such that domain of f is the set A itself and no two distinct different order pairs in F have the same first element, right? So if f is a function from A to B and AB belongs to F, means order pair belongs to that function, then f of A is equal to B, means f of A, value of function at A is equal to B. Now this A is your pre-image and B is the image, right? Where B is called the image of A under F and A is called the pre-image of B under F, right? Now the function f from A to B, it is denoted by f such that A is mapping, f is mapping from A to B, right? We write like this, that f is a function mapping from A to B. Looking at the previous examples, we can easily see that the relation in example 7 is not a function because the element 6 has no image. So example 7 that we did in our part 1, it means the element 6 was not having any image, so it is not a function. Again, the relation in example 8, it is also not a function because the element in domain are connected to more than one images, right, that we were talking about. Similarly, the relation in example 9 is also not a function. Now in this example given below, we will see how many more relations, some of which are functions and others are not. So let us now properly see that what are the conditions which a relation should obey to be a function. Now example number 10 is there. Let n is the set of natural numbers and R is a relation defined on natural number set such that R is xy, pair xy such that y is 2 times x and both xy should belong to n. What is the domain, codomain and range, and is this a function or not? Now the domain of R is the set of natural numbers. Why? Because you can put any natural number. It's an open question. Y is equal to 2x. Keep on changing the values of x, you will get different values of y, right? And so the codomain is also n, right? Codomain is also n. And range is the set of even numbers. Why? Range is what we obtain by putting. Okay, so I can put any natural number, but what will I get? I'll get like elements like y is 2, y is 4, like x is 1, then y is 2, x is 2, y is 4. So I'll get even natural numbers. So range is the set of even natural numbers, right? Now since every natural number n has one and only one image, you will get just one and only one image. So this relation is definitely a function, right? This relation is a function, right? Now let us take an example. Examine each of the following relation given below and state in which cases given reasons whether it is a function or not. Okay, so this is just a simple relation given here, right? No domain, codomain has been shown here. So my first relation is 2, 1, 3, 1 and 4, 2, right? It is such kind of relation. So is it a function or not? Okay, Now since you can see 2, 1, 3, 1, 4, 2, right? Means what you need to say is that no two ordered pairs should have same first elements. Second elements can be same, okay? It can be a many one function instead of being one function that we will study later in our higher class, right? But the basic thing you need to say is that no two ordered pairs have the same first element, okay? Different ordered pairs. So since 2, 3, 4 are the elements of domain of R having their unique images. Image is unique. For 2 you are getting 1, for 3 you are getting 1, and for 4 you are getting 2. So this relation is a function. For the second one are 2, 2, 2, 4, 3, 3, 4, 4. Now you see that the two ordered pairs, these two ordered pairs have the same first element, right? So two different images, 2 and 4 is corresponding to the first element 2. So this is not a function, right? Third one is you can see for 1 it is 2, for 2 it is 3, 3, 4, 4, 5, 5, 6, 6, 7. So every element has one and only one image. So this is again a function. Now definition number 6 is a function which has either R or one of its subsets as its range is called a real valued function, right? Means whose range is either set of all real numbers or one of its subset is called as real valued function. Okay, the value of the function is real, and if its domain is also either R or its subset, then it is called a real function, right? So we take an example, let n be set of natural numbers, define a real valued function f mapping from n to n, okay, n for natural number such that fx is 2x plus 1. So this is a rule that fx is 2x plus 1. This fx is means y, okay. Using this definition, complete the following table, right? So I have to put the natural numbers, right, x and I'll obtain y number itself, right? So that will also be a natural number. Like you put x as 1, I'll get f1 as 3, for 2 it is 5, as you used to calculate the value of the polynomial in your previous class 10th, okay? F of 3 is 7, f of 4 is 9, f of 5 is 5, 2 is 10 plus 1, 11, and like this, okay? Now some function and their graphs. So let us see functions, its types, right? And the first function, the basic function is your identity function. Identity function means as it is. So let R be the set of real numbers. So define the real valued function f mapping from R to R such that y is equal to fx equal to x, right? Y is equal to x or y equal to fx equal to x, right? For each x belongs to R, this is called as identity function. Why? Because when you put x1, you will get y same as 1. You will put x2, you will get y as 2. 3, 3, 4, 4 like this. So 0, 0, minus 1, right? So you will get the identical value. So such a function is called the identity function, right? Here the domain is R because you can put any real number. Range is also R because whatever you are putting, that is also coming. So range is also R. And the graph is a straight line. It passes through origin. You can know that 2, 2, 4, 4, 6, 6. If you plot this 2 minus 2, minus 4, minus 4, minus 6, minus 6, you get a straight line passing through origin. So y equal to x or y equal to fx equal to x is an identity function, right? Whose domain is R, range is R, and graph is a straight line passing through origin. Second is constant function. So a function mapping from R to R defined by y equal to fx equal to c, where x belongs to R and c is a constant, okay, and each x belongs to R, right? So y equal to fx equal to c means if I put x as say 1, then I'll get c at same constant. 2 will give me c, minus 1 will give me c. Like if for example this fx is 3, means in place of c it is 3. So 1 will give me 3, 2 will give me 3, minus 1 will give me 3, right? So I'll get a straight line like this, okay, which is parallel to your x-axis, right? So domain is any real number you can put, but the range is just the constant that we are getting, okay, that y is equal to, right? The same constant is the range. Polynomial function, a function f mapping from R to R, it is said to be a polynomial function if for each x in R, y is equal to fx equal to a0, a1x plus e2x square plus so on so up to anx, where n is a non-negative integer. And what are e0, e1, e2, an? They are real numbers. Like the function defined by, this is your cubic polynomial x cube minus x square plus x. This is your biquadratic x raised to power 4 plus root 2x. There are some examples of polynomial function. The quadratic polynomial, you know, general type is ax square plus bx plus c. Whereas the function hx defined by your x raised to power 2 by 3 plus 2x. This is not a polynomial function, right? You did it in your class 10th that the power should not be in fractions or negative. It should be a non-negative integer, right? So example 13 is define a function f mapping from R to R, y is equal to x square, x belongs to R, complete the table, and what is the domain and range of this relation, right? So means the function is y is equal to x square. So I have to put the values like few negative, few positive, and 0, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So at minus 4, I'll get minus 4 square is 16, then it is 9, 4, 1, 0. This you all can frame, right? So domain is any real number. You can put anything. I have just put few of them, but you can put any real numbers, right? But what is the range, right? The range you get is your x belongs to R, okay? X belongs to R. You're getting a real number. So the graph of f, you know, it is a quadratic polynomial, if you remember, right? And the means you are getting squares. Squares means, so see what kind of range you are generating. So the graph of y equal to x square, you know, it's a quadratic polynomial. So graph will be parabolic, right? The graph will be parabolic. For 1, I'll get 1. For 2, I'll get 4, right? For 3, I'll get 9, and like this. Okay, so this way, and similarly to negative values also. So I'll get a parabolic type of graph. Okay, so domain is the set of all real numbers, and range you are getting what you are getting, which type of numbers you are getting, right? You are getting the numbers which are in upward direction. Means the range you are getting is of positive real numbers only. Means whatever you put will always get the result in positive real number. Example 14 is draw the graph of function f mapping from R to R defined by fx equal to x cube. X belongs to R. So let us frame few values. f0 is 0, 1 is 1, minus 1 is minus 1, 2 is 8, minus 2 is minus 8, 3 27, minus 3 minus 27, right? So if you plot the graph, so cubic polynomial like quadratic polynomial do not go at this direction. It reverses this direction, right? And it goes down. Okay, so this is the graph of cubic polynomial. You can easily frame it. Rational function, function of the type fx upon gx, where fx, gx both are polynomial function of x defined in a domain. And the denominator, you definitely know, for a rational number or rational function to exist, the denominator should not be 0, right? Example 15 is to find the real valued function f mapping from r minus 0 to r. What is the meaning of this r minus 0? That means you should take a domain in which you will not put 0. Means all real numbers are divisible, but 0 you cannot take. Why? Because fx is 1 by x, and you know if x is, this function is only defined when x is not equal to 0. Why? Because if x is 0, it becomes undefined, right? X belongs to your r minus 0. Now complete the table. What is the domain and range? So you can see from here, I have substituted a few negative values and few positive values. Okay, so 0 I can't put, so that's why 0 is not in the table, and the corresponding values you will get. So which type of values you are getting? You are getting the negative values as well. You are getting the positive values as well. So domain, what is the domain? It is the set of all real numbers except 0. And range is also same. You will get all real numbers except your 0, right? And the graph is in this form. See, it is just becoming parallel to this x-axis, this y-axis, but never meeting it. Means it is not intersecting it, right? So it is like this, the graph of this function obtained as modulus function. Now modulus function is your called as absolute value function also, right? And the function f mapping from R to R defined by fx equal to mod x. Okay, so x inside these parallel brackets you will find for each x belongs to R is called as modulus function, right? And for each non-negative value of x, fx is equal to x. But for negative values of x, it is the value of the function is negative of the value, right? So that's why fx is x when x is positive and is minus x when x is negative. So that's why absolute value is always positive, like for 3, because 3 is positive, like, so fx means the element will come itself as it is. But if it would have been minus 3, right? Means if it is negative, x is negative, then it will come outside as minus of minus 3. So that automatically will become positive, right? So modulus just give me, means you can put any real number, right? But what kind of values you will obtain? Only the positive real number, right? So range you will get is the set of all positive real numbers, and the graph is same. For 2 you will get 2, for 4 you will get 4, for 6 you will get 6, for minus 2 you will get 2, for minus 4 you will get 4, for minus 6 you will get 6. Okay, so means the graph is not going to the downward direction, it is a V shape of graph. Always remember. So whenever you see a V shape of graph, it is always belonging to a modulus function. Then comes signum function. So a function defined by f mapping from R to R such that it gives just you 3 values. What? 1 if x is positive, your 0 if x is equal to 0, and minus 1 if x is negative. It is called as signum function, right? So domain is what you can put anything, any real number, but range is just these 3 values. So range is the set minus 1, 0, 1, right? And what is signum function? This is signum function. Fx is equal to your mod x upon x such that x is not equal to 0, right? Right? So see why it will give for positive real numbers, it will give you the value as 1. See, if I take x as say 3 again, so mod x upon x means it is mod 3 upon 3, right? Which is your 3 upon 3 and is 1, right? So that means when x is positive, the signum function will just give you value 1. But when x is negative, when x is say minus 3, what will happen? I take it as minus 3, it is mod x upon x. So this upper becomes 3 and it will be minus 3. So the answer is minus 1. And for 0 it is 0. So it will, whatever value I'll put, I'll get just 3 values, 1, 0 and minus 1. And the graph is just like this. See, the equal to sign is not here. Okay, it is strictly. So that's why a hole is kept here. So the graph is like this. Okay, for y equal to 1 and y equal to minus 1. For these, this is for positive values, this is for negative values, and this is for 0. Okay, greatest integer function. So a function f mapping from R to R defined by fx equal to this big bracket inside a function is enclosed, and for x belongs to R. This is called as the greatest integer function. And assume the greatest integer, value of greatest integer less than or equal to x, right? And it is called as greater integer function. Okay, so let us understand this greatest integer function with the help of your number line. So see, this is your number line and this is my element 0. This is 1, this is 2, this is say minus 1, this is minus 2. Actually, greatest integer function is the value which is immediately to the left of x. Okay, so means if I take minus 2, means it is itself an integer. So like modulus, it will not be plus 2, it will be itself. But if it is say like minus 1.5, okay, means the value which will come out of it will be a full integer, right? Full integer, right? It cannot be in decimals or something like this. And that as like modulus function, the negative positive signs are not changed. It will be as it is. Now what will be the value? Like where is minus 1.5 lying? Here. Okay, here between minus 1 and minus 2. Now you have to look for the integers which are towards the left of this. Okay, so 1.5 minus 1.5 is somewhere here. So which integer is towards its left? It is minus 2. See. So the answer is minus 2. Right? If it is say 1.5, say it is 1.5 plus. So which value is towards the left out of full integer 1 and 2? It is 1. So the answer is 1. Right? Similarly, for minus 0.5, which integer is towards the left? Minus 0.5 is somewhere here. It is minus 1. Okay? Towards left is minus 1. So this is how we define the greatest integer function. And this is the graph. Means it shows the values it assume. Right? That if it is lying between your 1 and, means whatever the values meet, if you take an integer between them, so its value will be towards the left function. That means it is 1 only, right? Except when the value is itself 2, means you take inside 2, then only this will be there. So that's why a void is there, right? And if it is between 2 and 3, the value will be just 2. If it is between 3 and 4, it is just 3, right? So this way, greatest integer function can be defined. Now the algebra of real functions. In this section, we will learn about how to add two real functions, subtract a real function from another, multiply a real function by a scalar. Okay, here by scalar we mean a real number, and multiply two real function and divide one real function by the another one. So addition of two real numbers, let f is mapping from x to r, g is mapping from x to r, means you can see that both the functions are having same domain, same range. Okay, b any two real functions where x is subset of r. Okay, x is subset of r. Then we defined f plus g, means the addition of these two functions that will also be mapping from x to r, right, having the domain as x and r as the codomain, right? And f plus g times x is equal to, means f of x plus g of x, right, for all x belongs to x. Similarly, if f is mapping from x to r, g is mapping from x to r, we two real functions, x is subset of r, then f minus g will also be mapping from x to r, and f minus g of x will be fx minus gx for all x belongs to x. Multiplication by a scalar, so let f is mapping from x to r be a real valued function and alpha is any scalar, right? So by scalar multiplication, we mean we are multiplying with a real number. So the product alpha f, that will again be a function from x to r, right? And will be defined as alpha f times x, means alpha times f of x for x belongs to x. Multiplication of two real functions, right? So a function f mapping from x to r, g mapping from x to r. So product fg will also be mapping from x to r and will be defined as fg of x is f of x into g of x, means multiplied to the two functions and you'll get the answer for all x belongs to x. And this is also called as pointwise multiplication. Quotient, f and g are two real functions and they are mapping from x to r again, like this we took, and x is subset of r, then quotient of f and g is denoted by f by g and is a function f by g of x is your fx divided by gx, and gx is not equal to 0 for x belongs to x. So let us apply it in problems, and the problems gives, let's take first example number 16. Fx is your x square, gx is 2x plus 1, right? So you have to find f plus g of x, f minus g of x, f into g of x, and f by g of x. So simply means you have to add, subtract, multiply and divide the two functions. So f plus g of x means the addition of these two. That will give you x square plus 2x plus 1. The difference is x square minus 2x minus 1, right? Because minus of 2x plus 1 will give you x square minus 2x minus 1. And multiplication means x square into 2x plus 1. So this is the result. And division will give you your f by g, means x square upon 2x plus 1. Now you know that this denominator should not be equal to 0, means x is not equal to minus half, because that will make this function not defined. Like in 17, fx is root x, gx is x. So you need to find all of them, right? So sum is your root x plus x simply. Difference is root x minus x. Product is root x into x, that is x raised to power 3 by 2. And division is root x by x, right? So it means this x raised to power half upon x raised to power 1, bring all to numerator, that is x half minus 1, that is x raised to power minus half, right? And this exists for x not equal to 0. Now let us take few miscellaneous examples also. Like, so the first one is your example 18. Let R be a set of real numbers defined by real function f mapping from R to R. Fx is your x plus 10. You have to sketch the graph of this function, right? So I'll take 2, 3, 4 values, like f0 is 10, f1 is 11, 2 is 12, like this, and f10 is 20, right? Say if you take few negative values also, f of minus 1 is 9, minus 2 is 8, minus 10 is 0. As you plot the table, right, you can frame a table as you have plotted while plotting the graph, right? So the graph will be your, like, generally you just need two values, as we did in our linear inequalities also. You need two values where it is touching the x-axis and y-axis, right? So when it is 0, it will give you 10, and when minus 10, it will give you 0. So this is the graph, how it is sketched. and the function f defined by fx equal to mx plus c, x belongs to R. It is a linear function. Why? Because it's, it's a linear polynomial, right? Where m and c are constants, and above function is an example of linear function, right? Example number 19, let R is a relation from Q to Q. Q means, rational numbers, and R is defined as your ordered pairs AB. AB belongs to Q, and A minus B belongs to Z, means difference is an integer. So AA belongs to R for all A belongs to Q, right? And AB belongs to R implies BA belongs to R, means as AB is means of following this rule, so similarly BA will follow the same rule, and AB belongs to R, BC belongs to R implies AC belongs to R. Now dear students, this is a very important question. This is actually, you will start your relation function in class +2 with this topic, that how to prove the relations as equivalence relations. Okay, so here let us work out it at the level of +1 class itself. So AA belongs to R. Actually relation is that if we take two rational numbers, the difference is an integer. So AA belongs to R. AA belongs to R means the first element is A, B is also A. So A minus A, what will it give you? 0. Is it an integer? Yes. So it follows that AA belongs to R, belongs to our relation. AB belongs to R implies BA belongs to R. Now AB belongs to R means A minus B is an integer, right? So see, now you can do it with the example. If I take A as 1, B as 2, right? So A minus B means 1 minus 2. What is it? It is minus 1. Is it an integer? Yes. So BA belongs to R. BA belongs to R means 2, 1, right? Like 2, 1. So 2 minus 1. Is 2 minus 1, which is 1, is an integer? Yes. So AB belongs to R also implies BA belongs to R. Similarly, AB and BC belongs to R, means AB belongs to R means A minus B is an integer, B minus C is an integer, right? So add up both of them, A minus C and B minus C. What does it give? It gives you A minus C, which is also an integer. So that means your A minus C is also an integer, means in the same rule, right? As AB belonging to R means A minus B is an integer, BC belongs to R means B minus C is an integer. So A minus C belongs to Z means AC belongs to R, right? So you can do it with the help of an example also, right? You can take like 1 minus 2. We take say 1, 2 belongs to R, right? So this is AB belongs to R. And BC means, say I take 2, 3 belongs to R, right? 2, 3 belongs to R, right? So 1 minus 2 is minus 1, which is an integer, belongs to Z, right? 2, 3 means 2 minus 3 is again minus 1, which is an integer. Now what is AC? AC means your 1 and 3. So 1 minus 3 is also an integer, which is minus 2 is an integer. Okay, so that's why this is implied. Quantities let f is 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 is a linear function from Z to Z. Find fx. You have to find the function. So again, you have to see which type of function is this. Okay, so since it is a linear function, linear function is of the form mx plus c, right? So since 1, 1, 0, minus 1 belongs to R, so let us place in place of x this 1 and in place of the y value as this 1. Okay, so I'll get f of 1 is m plus c, which is equal to 1. Okay, and f of 0 is c. You can see from here, f of 0 will give you, place x as 0, you'll get c. C is minus 1. So put that c here. So m is your 1, 1 plus 1, that is 2, right? So my function is your, put back the values of m and c, I'll get function as 2x minus 1. Find the domain of the function. Now how do we get the domain of the function? See this function. This is a quadratic polynomial divided by quadratic polynomial, right? So for this function to exist, what should be there? This denominator should not be equal to 0. So I have to delete those values at which makes this function 0. So for it, I have to factorize this function, right? So the factors are x minus 4 and x minus 1. So if x is 4, then also this function will become 0. If x is 1, then also it will become this, but I am talking about the denominator. If x is 4, then also denominator is 0. If x is 1, then also denominator is 0. And if denominator is 0, and you know that a rational function should have a non-zero denominator, right? So that means I can put any value, but I should not put what? 1 and 4. So means what is the domain? Domain is set of all real numbers except this set having two elements 1 and 4. Okay. Example 22 is a function f is defined by fx is 1 minus x for x less than 0 is 1 when x is 0 and x plus 1 when x is greater than 0. Draw the graph of fx, right? So here you can see you can put few values. That means x is less than 0, then it is defined like this, right? So f of minus 4, you will select the function like this. So it is 1 minus minus 4 is 5, f of minus 3 is your 4, minus 2 is 3, minus 1 is 2. And when you have to take your positive values, so you'll take the function like this. So f of 1 will give you 1 plus 1, 2, 2 will give you 3, 3 will give you 4, 4 will give you 5, right? So when I'll plot the graph of the function, you'll get a V shape of graph, right? And when x is 0, the value is 1. So 0, 1 is here. So you'll get a V shape of graph. So let us start with exercise 2.3. Which of the following relations are functions? Give reasons. If it is a function, determine its domain and range, right? So let us see this. So domain of the function relation, domain of the relation is 2, 5, 8, 11, 14, 17, right? Domain of the relation is this. Now since every element of domain has a unique image, right? 2, 1, 5, 1 is no two ordered pairs are having same first element, right? Same first element. Okay. So this is a function, right? So domain of the function is again the set of first values. And what is the range? It is 1. Okay. So shall I say it is a constant function? Because constant function has just single element, the constant value. Like the function is like y is equal to 1. Whatever you put, you'll get the answer as 1, right? So this is an example of your many one function or constant function. Second is these pairs. Now observe the pair. Relation is having domain as 2, 4, 6, 8, 10, 12, 14 and, right? Now since, can you find any two pairs which is having same first element? No. So this again is a function. So the domain of the function is the domain of relation itself, and the range is the second values like 1, 2, 3, 4, 5, 6, 7. You can see from it. Now look at the third one, 1, 3, 1, 5, 2, 5. Now see, these two ordered pairs are having the same first element, right? So this relation is not a function, right? Now let us discuss about the method of finding the domain and range of the function when rule of function is given. So how to find the domain of the function fx? It is the set of all those real numbers for which the function is real. It should be real and finite. That is, some x belongs to R does not belong to the domain of a function fx if fx approaches to infinity for this value of x, or fx assumes a value which is square root of a negative real number, right? So means the function should not approach to infinity, and in case of square root function, the square root should not be a negative real number, because in that case it will not be a real function, it will be complex one. So case 1 is when fx is rational function like gx and hx are the polynomials, and hx is equal to 0, right? Then hx equal to 0 case is there, means you have to take those values in which hx is not equal to 0, like we did in our previous example, right? So that those values which make the function non-existing does not belong to the domain. And in case of square root function, only those points we will take for which your gx is greater than equal to 0, because negative value will make it a complex function. Okay. And case 3 is fx is 1 upon root gx, then only those points which means now here you see when it was just root gx, so gx should be greater than equal to 0. But when it is in the denominator, so it cannot be 0 also. So in that case, I'll take gx positive only. Only those values belong to the domain, right? And range will be the set of values of y for which the function x in the domain. Okay, means it is the set of all y values, right, for values of x in the domain, right? So let us see how to do the functions. Various functions need to be tackled in various ways. So let us see. The first question is fx is minus mod x. So since mod x is defined, right? You know mod x is defined. It is a real and finite for all real numbers, right? You'll get values, okay, right? So minus mod x is also defined for all real numbers. It is defined means you can put any real number. It will not make it non-defined. So domain is whatever you can put. So the domain of the function is R. Now to find the range, you know what is the range? Mod x is itself positive, greater than equal to 0. Mod x is positive, right? But the function is not mod x, it is minus mod x. So if mod x is greater than equal to 0, what will be minus mod x? It will be less than equal to 0. So you know how to show means my function is less than equal to 0. So in real number system, how do you show something less than equal to 0? It is minus infinity to 0 semi-closed interval. Okay, towards this side the open bracket is there and towards this side the closed bracket is there. Okay, because function is less than equal to 0 means the range of the function is set of negative real numbers. So from minus infinity to 0 semi-closed. And if it would have been just root this mod x, so it would have been from this, means then this would have been the case. So it will be from semi-closed 0 to infinity. Okay. Second is your root function, root 9 minus x square. So y is root 9 minus x square, right? So this will be defined, you know, when this, as it was told in the note, that this 9 minus x square should be greater than equal to 0. Okay, greater than equal to 0. So that means you can take it in factorized way also, right, or non-factorized way also. So let us see this way also. This will give you greater idea of few other things also. So like a square minus b square, a plus b into a minus b is positive, right? So when is the product positive? When both the factors are positive or when both are negative? In that case also the result is positive, right? Plus into plus is plus and minus into minus is also plus. So that means my 3 minus x is positive, 3 plus x both are positive. So this will give you minus x greater than equal to minus 3, x greater than equal to minus 3. I'll multiply by minus 1, I'll get x less than equal to 3 and x greater than equal to minus 3. So see, if I need to, because we have done linear inequalities, so this concept is very clear to you. Greater than equal to minus 3, less than equal to minus 3 means x belongs to closed interval minus 3 to 3. Because equal to sign is there, so the close bracket will be there. Or case number 2 is when both are less than equal to 0. So minus x less than equal to minus 3, x less than equal to minus 3, multiply by negative sign, x greater than equal to 3, x less than equal to minus 3, right? So x greater than equal to 3 means towards this side, less than equal to minus 3. Is there anything common? No. Okay, so this case is impossible. So what is the domain? Domain is decided from this case only, that it is closed interval minus 3 to 3. Now how to find the range? Be careful in selecting how to find the range. For range, I'll take y as this, okay, and convert this y to x, right? I'll convert y to x. So for changing y to x, I'll square it first, okay. Express x square as 9 minus y square and x will be plus minus root 9 minus y square. So previously the question was y equal to root 9 minus x square. So representing this y equal to x in the form of x equal to y is the process to find the range. Okay. Now x is real if this term inside the root is positive. Again the same thing as we did in first part. 9 minus y square should be positive. So that means 3 minus y into 3 plus y should be positive. So two cases again. Product is positive if both the factors are positive or both are negative. So again see, if this case gives you again in the same way, it will give you the closed interval minus 3 to 3. See, minus y is greater than equal to minus 3 or multiply by minus 1, y less than equal to 3 and y is greater than equal to minus 3 means y is, this is okay. So y is lying between minus 3 and 3. So again, this is how it is represented on y-axis, right? So you will get this. These values of y satisfy this condition. Case number 2 again, it will give you y greater than equal to 3 and less than equal to minus 3. So means no common value, right? So this case is your impossible. So, but now see, here lies the main logic, right? What is that logic? That the y y as per the first part is always positive, right? Because I have chosen my domain on the basis of that this result is always positive, right? So y is from -3 to 3 means I have to reject all those negative values because y must be positive. So I have to delete the negative values. So from where I will take the function? From 0. I'll start my values from 0. So means instead of taking that -3, -2, -1, I'll start with 0. So y is lying between 0 and 3, right? So that is the required range, that is closed interval 0, 3. I'll reject all the negative values. Okay, this is how our square root function is taken. Number 3 is a function f is defined by fx is 2x minus 5. Write down the values of f0, f7, f minus 3. So I think this is very simple. You have just to replace x by say 0, it becomes minus 5. So this is the value of the polynomial you have calculated. So this way this question can be done. The function t which maps temperature in degree Celsius into temperature in degree Fahrenheit, t of c is 9c by 5 plus 32. So t of 0 is, you can just put c as 0. It becomes your, replace c by 0, it becomes as 32. So again these are the values, okay, like t28. Now t of 0 is your 32 and replacing c by 28 we get t28 as 82.4. Similarly t minus 10 is your 14 and tc is 212, so you'll put it in your given equation and get the value of c as 100. Okay. Number 5 is find the range of each of the following functions. Now let us try out range in some different way, right? Here the domains are already described and these are simple functions. So this is also one way of finding out the range. Okay. So fx here is 2 minus 3x and x belonging to real number and x is positive, right? X is a positive real number. Okay. Now consider x greater than 0. Now I need to check how is my y behaving. Y means it is fx. So I'll change this x to 2 minus 3x as we did in this topic of linear inequalities, right? So first thing is I'll just change this x greater than 0 to 2 minus 3x, right? And in that way I'll get conditions for fx, right? So as x is greater than 0, first thing is I'll make x as 3x, right? Minus 3x. So multiply both sides by minus 3, I'll get minus 3x is less than 0. Why? Because multiplying with negative sign changes the direction of inequality. Now add to both sides so that I can make it as 2 minus 3x. So it becomes 2 minus 3x less than 2. That is my fx. This is my function which is less than 2 for x positive, right? So this value of means your fx less than 2 is actually the range. So fx less than 2, strictly less than 2 means it belongs to this your open interval minus infinity to 2. So this is my required range and domain is this, okay, x greater than 0, that is from 0 to infinity. Second is fx is x square plus 2 for x belonging to R, right? Now x is belonging to R, so we know for any, I just want to go to this, okay. So see, x belongs to R implies a square of any number is positive, that is greater than equal to 0. Okay. Now adding 2 both sides, what do I get? X square plus 2 is greater than equal to 2, right? So that means fx is greater than equal to 2, right? So that means my function is greater than equal to 2 means it is belonging to your semi-closed. Greater than equal to 2 means semi-closed interval 2 to infinity. So this is my range of the function. Third is fx equal to x. So you very well know it, it is an identity function. So its domain is real number. So range is also the set of real numbers. Let us start with our miscellaneous exercise on this chapter number 2. The relation f is defined by fx equal to x square when x lying between 0 and 3, 3x when x lying between 3 and 10. And gx is x square when x lying between 0 and 2 and 3x when x lying between 2 and 10. Show that f is a function and g is not a function, right? Now see that we can do this question in many ways. Like the best ways to understand is just make ordered pairs, right? And you have to means all other values are different. Definitely for between values 0 to 3 the function is defined as x square. From 3 to 10 it is defined as 3x. Similarly for gx, right? So just one checking will help me to solve this question. As see, I'll put x as 3. As at 3 there are two different values. So when I'll start making my ordered pairs, so when I'll put 3, right? So 3 is defined at x square will give me 3 square, that is 9. So one ordered pair I receive as 3, 9. Now also at 3 the function is defined as 3x. So when I'll put 3, right, means x3. So the second value 3 into 3 will also give me 9, right? So means that at both the values with both the defining, at 3 the function is getting the same your image, right? So definitely this my first one is a function. Now for the second one, see, 2 value is repeating. It means the value at 2 is both ways in the defining, right? So when I'll make the order pair with 2 for x square, it will be your ordered pair 2 and 2 square is your 4, right? Whereas for the second one, it is 2, right? It becomes 2 into 3, that is 6, right? So 2, 6 and 2, 4. You can see that these two ordered pairs have different second elements, but the first element is same. So it is not allowed because it is belonging to G. Therefore, G is not a function, whereas your f is a function, right? So this is all the discussion which has been done to make the means conditions or find out the conditions that f is behaving as function and G is not a function, right? Number 2 is fx is x square. Find f of 1.1 minus f of 1 upon 1.1 minus 1. So means f of 1.1 means 1.1 whole square, and f of 1 is minus 1 square upon 1.1 minus 1, and it gives you 2.1. Find the domain of function fx is x square plus 2x plus 1 upon x square minus 8x plus 12. So we did this question and example also. Now the domain will be those values, means all the values except the values at which this function becomes 0, right? This denominator becomes 0. So let's find x square minus 8x plus 12 equal to 0 will give you the factor x minus 2 into x minus 6 is 0. That means the values are 2 and 6. So except 2 and 6, you can put anything. So what is the domain? R minus your interval to 6. Number 4 is find the domain and range of the real function defined by fx equal to root x minus 1. So as we did in root n minus 9 minus x square. Okay. So again, you know, in a root function, inside this term should be positive, greater than equal to 0, right? So x should be greater than equal to 1. Like x minus 1 is greater than equal to 0, means x is greater than equal to 1. So that is the domain. Domain is means greater than equal to 1 means semi-closed interval 1 to infinity. Now to find the range, put y equal to fx, that is your root x minus 1. Now what we need to do, we need to convert x in terms of y. Express x in terms of y. So for it, firstly square. Y square is x minus 1, or x is 1 plus y square, right? Now I have to remember the conditions for domain also, like we did in our earlier questions, right? So domain says that my y is positive, right? This is y, x minus 1. So this is positive. So y is greater than equal to 0. This condition must be in your mind, right? So x is a real number, and for all y belongs to R, what will be the set range of this f using these common values of 1 and 2, right? It will be your y positive, right? Y is greater than equal to 0, right? So that makes your ranges from semi-closed interval 0 to infinity, right? Semi-closed interval 0 to infinity. Number 5 is domain and range of fx equal to mod of x minus 1. So again, you know that in a modulus function, always domain is any real number. You can put anything. But range is the set of those values for which the function inside it is that comes always positive. That is mod x minus 1 is always greater than equal to 0. You know only positive values come. So that means my fx is greater than equal to 0. Now those real numbers I need to take in range which are positive. That means from 0 to infinity, including 0, that is semi-closed interval 0 to infinity, right? So domain is R, but range is from 0 to infinity. Number 6 is f is x square upon 1 plus x square. X belongs to R. Be a function from R to R. Determine the range. So let us first, actually this domain is given already. So means fx equal to x square upon 1 plus x square. Right? Now to find range, what we need to do is, we need to convert it in terms of means x values. Or there is one other way also. Let us check it out. That y is my x square upon 1 plus x square. And this y is my positive. Why? Why y is positive? because you see that x square is positive. Okay, x square is positive, and definitely 1 plus x square is always positive. So positive upon positive is a result which is always greater than equal to 0. Okay, now again from number 1, what can you write y as x square upon 1 plus x square, and can I write it as adding and subtracting 1 in the numerator as 1 plus x square minus 1. Now separate the numerator, 1 plus x square upon 1 plus x square minus 1 upon 1 plus x square, right? So this is some value which we obtain, 1 minus 1 upon 1 plus x square, right? Now you see this is something positive. 1 upon 1 plus means even if this x is 0, this is something means 1 upon 1, and even if you give different values to x, so it will be, this result will always be less than 1 for all x belonging to R, less than number 1. Okay, less than 1 for all x belonging to R, right? So what do I get that from my 2? Now go for the common conditions. Now it says that my y is positive, y is positive here, and your y is less than 1 you got here. So that means my y is greater than equal to 0 and less than 1. So means range is from semi-closed interval 0 to 1. Question number 7 is fg mapping from R to R be defined respectively by fx equal to x plus 1 and gx is 2x minus 3, and find f plus g, f minus g, and f by g. So it is very simple, means f plus g means you have to add up both of them. So x plus 1 plus 2x minus 3 is 3x minus 2. Their difference is minus x plus 4. Their ratio is x plus 1 upon 2x minus 3. And provided this denominator is not equal to 0 means x is not equal to 3 by 2. It is f is your 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 is a function from z to z defined by fx equal to ax plus b, the linear function. For some integers a and b, you have to find the values of a and b. Okay, so again, you know, we did a question in example like this also. So we will put, take means f1, 1, this first one, and in place of x I'll put 1, and in place of y I'll put 1. Okay, so means fx is your y, so that is 1. So 1, 1 belongs to f, means f of 1 is 1, right? The value of function at 1 is 1, right? So put it here. So I'll get in place of x, it will be a plus b is equal to f of 1 is 1. So it is a plus b is 1. This is the first equation. Take the second pair also. So that 2, 3 belongs to f means your 2a plus b. Okay, 2a plus b, that is equal to 3 because f of 2 is 3. Now solve by using simultaneous linear equation and you'll get a as 2 and b as minus 1. Number 9 is let R is a relation from n to n defined by R is equal to AB, AB belongs to n, and A is equal to B square. Are the following true? AA belongs to R for all A belongs to n. AB belongs to R implies BA belongs to R, and AB belongs to R, BC belongs to R implies AC belongs to R. Justify your answer in each case. Now this is a very important concept which you will learn in your class 12. That is the proving of equivalence relation, where we prove this reflexive, symmetric, and transitive properties. Okay, but this year just let's take this question as it is, that we know, see, I have to frame my example that A is equal to B square, right? And AB both are natural numbers. Now you know that, and it should hold for all natural numbers, mind it, right? So we know that except there is one natural number 1 which is equal to its square, right? Which is equal to its square. But I told you that even if one example is there which does not satisfy the conditions of the relation, in that case your relation is not existing, right? So AA belongs to R means that A is equal to A square. A is equal to A square. Now is it possible in case of any natural numbers, right? Except one, means in any other system also, that you will find except one that no number is equal to its square. So that means AA does not belongs to R. AB belongs to R implies BA belongs to R. So AB belongs to R means A equal to B square, right? So can it be true if A is equal to B square then B is equal to A square? I don't feel so. So let us take an example. AB belongs to R implies BA belongs to R is not true. Why? Because if I take 4, 2 belongs to R, right? Now A here is 4 and B is 2. Like I took an example in which A is equal to B square, right? But Now reverse it. Find that 4 is 2 equal to 4 square? No. So that's why 2, 4 does not belong to R. Similarly, the third one, AB belongs to R means A equal to B square. BC belongs to R means B equal to C square. Right? Now, if I put this B as C square in equation number 1, I will get C square whole square, that is C4. So A equal to C4 not equal to C square. So that means AC does not belong to R. If I take an example, AB as pair 16, 4, right? Because you know that my A equal to B square, right? That 16 is equal to 4 square. Similarly, 4 is equal to 2 square, right? But you link up the connection between this A and 2, AC, okay? 16 and 2. Now here you find that 16 is not equal to 2 square. That means this statement is false. This is not obeying the condition. Number 10 is, let A is set 1, 2, 3, 4, B is 1, 5, 9, 11, 15, 16, and F is a function which is 1, 5, 2, 9, 3, 1, 4, 5, and 2, 11. Are the following true? F is a relation from A to B. F is a function from A to B. Justify your answer in each case, okay? So we need to look up at the pairs, okay? See 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. Like, so if you focus here, 2, 11 and 2, 9, right? So they do not follow the condition of being a function. Why? Because the two ordered pairs, different ordered pairs with second different elements have the same first element, right? So this is not a image of 2 is not unique. So that's why F is not function from A to B. Whereas now means if I start framing A cross B, it will be like 1, 1, 1, 5, 1, 9, 1, 11, 2, 2, 1, 2, 5, 2, 9, 2, 11 like this, okay? So can I find this 1, 5 means first element from A and then second element from B, like 2, 9 you can see, 3, 1 you can see, 4, 5 you can see, and moreover 2, 11 you can see, right? So means this relation means these set of elements is the subset of your Cartesian product, okay? So definitely it's a relation from A to B, right? So it is a relation from A to B, but it is not a function. Number 11 is if F is subset of Z cross Z. Z cross Z means integer and means from integer to integer. Defined by F is equal to AB, A plus B, where AB belongs to Z. Is F a function from Z to Z? Justify your answer. So we need to take an example, okay, where we can justify whether we can check it as a function or not. And we need to frame a proper example, okay. It means if even one example can deny it, that will be taken. Consider that it is not true, okay. So let us search and work it for it that AB, A plus B, AB belongs to Z. So if I took A, B both has 1, what does it becomes? This AB will give you 1 and A plus B will give you 1 plus 1, that is 2, means 1, 2 belongs to F. And if AB are both minus 1, right, then we get it as, say, AB as again 1, but A plus B in this case is minus 1, that is minus 2, right? So what happened? Two ordered pairs with different second elements but same first element. So F image of 1 is not unique, so it is not a function, right? So an example we took because integers they cover both positive negative numbers, so that way the image is not unique, that's why it is not a function. Number 12 is A is a set 9, 10, 11, 12, 13. F is a mapping from A to N. B defined by Fn is the highest prime factor of N. Find the range of F. Okay, so A is this set and Fn is your highest prime factor of N. So let us make the factors of 9. Okay, and you have to take the highest prime factor. Like the factors of 9 are so many, 1 into 9, 3 into 3. Okay, but out of them the highest prime one is 3, right? And if you take the factors of 10, so it will be like 1 into 10, 2 into 5, right? So 1 into 10 means it's not having any prime number, but if I take the factors as 2 and 5, the highest prime number one is 5, right? For 11, 1 into 11, so 11 is the highest one. For 12 it is 4 3s are 12 or 2 6 are 12, like this. So means 3 is, you will find 3 as the highest prime factor. And for 13 it is 1 into 13, that is 13 itself, right? So range of F, it is the set of F images of elements in domain, right? So means this your ranges 3, 5, 11, 3, 13. So you know that we should not repeat the elements. So it will be just 3, 5, 11 and 13. Now the summary, that in this chapter what we studied. So let us revise. What was ordered pair? A pair of elements grouped together in a particular order. Cartesian product A cross B for two sets. It is the set of ordered pairs AB where A belongs to A and B belongs to B. Similarly for R cross R, the ordered pairs XY where XY both are real number, and ordered triplet will be of the form R cross R cross R is XYZ where XYZ all belonging to R. Two ordered pairs AB XY will be equal if first is equal to first, second is equal to second. A is equal to X and B equal to Y. If number of elements in A is P, in B is Q, then number of elements in A cross B is equal to P into Q. And A cross phi is phi. In general, A cross B is not equal to B cross A. A relation R from set A to B, it is the subset of Cartesian product A cross B and is obtained by describing relationship between the first element X and the second element Y of the order pair in A cross B. The image of an element X under relation R is given by Y where XY belongs to R. The domain of R, it is the set of all first elements of the order pairs in a relation R, and range of this relation R, it is the set of all second elements of the order pairs in R. And then a function F from set E to set B, it is a specific type of relation for which every element of X of set E has one and only one image Y in set B, right? And we write F such that F maps from A to B, okay, where F of X equal to Y, means image of X under F is Y, right? X is called the pre-image and A is the domain and B is called the codomain of F. So I hope whatever is taught is clear to you. Revise this topic well, and thank you so much.